Use tracing paper and a series of rigid transformations to determine if these two polygons are congruent, and if possible, find the lengths of z and y. So I did copy, whoops, this had things I erased too, but I did copy both of these into a program where I could manipulate them a little bit better, but even then it was not exactly what I wanted. So here's a copy of this. If I slide point W to point A, and then I do a rotation until A lines up with D, I do get the pieces to line up. So I'm convinced that they are congruent to each other based on the fact that there appears to be two transformations I would do. I would translate point W to A. Let me write that down. So if I'm asked for a series of rigid transformations, I may say something exactly like this. Translate point W to A. So W gets slid all the way over to where A is. And then I'm going to rotate that shape with the W, X, Y, Z clockwise until WZ lines up with DA, right? And then we're done. So that's our series of rigid transformations. Now that we've got that, these two things are congruent to each other, right? There's no scale factor. The scale factor is 1. So what's nice about that is I don't have to do any arithmetic because the scale factor is 1. I know that z, right, lines up with the part that's 15, so z will be 15. And I know that y is going to land at the part that's 3. So we've got z is 15 units and y is 3 units.